Okay. Good afternoon. My name is Bryden Oliver. I'm a principal software engineer with Quest Software, and I've been working in this area for 18 years at Quest. I work on the Spotlight family of database performance monitoring products, and I now provide a high-level technical overview across that whole portfolio and other bits of our portfolio. And what we're going to talk today about is our experience building Spotlight Cloud and some of the challenges and things we did with Cosmos. Okay, so our agenda for today was what problem were we trying to solve with Cosmos? What is CosmosDB? So a little bit on what are the key features of Cosmos that help us. What are the problems we encountered? And then example architecture for using CosmosDB for the storage. And that includes the entire architecture. So it's not just Cosmos, it's what other bits of Azure we utilised, which isn't very much. Where were the pitfalls for us? And then did it actually work out for us? And what extra things we got by using Cosmos that we wouldn't have got from some of the other solutions. Okay, so our problem is we ingest data at about 1200 requests a second and about 20 kilobytes in every request. And we wanted to write that data straight into Cosmos immediately. And we egress data at about 1 request a second and maybe about a megabyte return per request. We also wanted some way of adding disaster recovery and high availability to our solution. We wanted it to be cheap to maintain, as everyone does, and really easy to build. And we expected the size and request rates to grow as we started selling the product more and more. So we needed something that would scale up with us. So we looked at CosmosDB. CosmosDB is an evolution of DocumentDB, which is the old Azure sort of NoSQL database offering. We'll look mostly at the SQL. We use the SQL interface mainly, but most of what I'm presenting here translates equally to all of the other ways you can talk to Cosmos. So it's a platform as a service database offering, meaning it's almost completely managed for you. It's very easy to configure and maintain, and almost everything is managed for you. That you get to choose a few things like replication and stuff like that. And the other thing about it is you pay for storage and compute separately. So you pay for, they charge you for compute and they charge you for storage. And the unit of measure for compute is what they call request units. Now we'll come back to this storage and compute being charged separately later on. That becomes quite important. It offers multi-data center replication with almost no maintenance. It does cost more though, so they charge you for the storage and the compute again for the second copy. Index is automatic. You can reduce what is indexed though. They do give you control of that. So you can reduce your costs significantly by turning off indexing for stuff you will never query. It splits your compute and storage cost, as we said before, and that's somewhat theoretical rather than actual. So we'll come back to that piece later. But what was the real thing with Cosmos to us? The SLA is really brilliant. And the reality when we've actually started using it was actually better than what they promised. So that's really the selling point. And of course it offers a fantastic reduction in day-to-day management. We now have almost no management. We've got a few alerts set up and that's it. Okay, so what were the problems we encountered? The main one is it's expensive compared to its competitors. And when we looked at it, it was between 1.5 and 4 times more expensive than any competition. It's not as configurable as the other solutions. Like the other solutions, we could stop, we could change things, and therefore you could go on and manage things better. And if you only need some of the features, then the extra cost wasn't worth it. But we actually wanted most of the features, so when we went through the analysis, it became quite clear that cost wasn't as much of an issue as it first appears. So here's a picture of our example implementation. So we built our system out of 2 data centers, but you can actually add more data centers on here. And we built it using CosmosDB replicated between the 2 data centers. And then there is a deployment of an Azure Function app, which is the thing that actually does the writing into CosmosDB in each of those data centers on the front. And then there is what's called an Azure Traffic Manager, which directs the load to data center 1 or data center 2. Okay, so that what we came up with in consultation with Microsoft, and that was their recommended way to try and attempt this solution. And it looks like a fairly simple solution for most customers' use cases. So I'll just run you through what the other pieces are that aren't Cosmos, you may not be familiar with. So Azure Functions is basically a platform as a service for websites or web services. So it lets you deploy web service endpoints very quickly and very easily. It's very low cost and very high scale if you deploy it using what Microsoft call a consumption plan, which is where they spin up extra virtual machines or nodes to cover your load. It's similar to AWS Lambda, if people have heard of that, but it's more flexible than that. It has a very easy programming model. The developers will love how easy it is to create, deploy and debug stuff with Azure Functions. It's very simple to integrate with Cosmos. It also integrates very well with Application Insights, which is Microsoft's diagnostic and monitoring solution for Azure. So you can get very good diagnostics of what's going on in your solution. So what is Traffic Manager? Traffic Manager was a DNS-based traffic routing solution. It can reroute between web service deployments either evenly or as a failover mechanism. So you can run with data center 1 hot and data center 2 cold, or you can run hot, both things, requests going to both data centers. It's very simple and very configurable and very cheap. It gives a very good, robust and fairly easily maintainable high availability and disaster recovery solution. So it'll detect if one of those data centers goes down and route all the requests to the other. It doesn't provide a perfect solution. So if you can't tolerate short outages, you're going to have to build something else on top of this or have a look for another solution. So you can get short outages of up to a minute. It relies on callers honouring domain name server time to live. Some things don't. So you will find that this solution won't work for absolutely everything. Okay, so we'll go back to our example implementation just to recap. So we've got a traffic manager routing all of the requests into one or other of the Azure functions. which we have on a consumption plan, and then we've got CosmosDB. Now, for our solution, we find that CosmosDB is 95% of the cost here. So the other pieces you basically are so cheap that you don't even need to worry about it. So that was a good thing to find. Normally, we would have paid quite a lot for hosting of our web service and all of that, in addition to the database, but with this solution, suddenly the hosting costs for our web service are largely gone. They're so small we don't really notice them. Okay, so there's a few pitfalls in all of this, and most of them aren't really very well documented. So if you read the Microsoft documentation, they won't tell you these pieces, but they are fairly easy to avoid. So the way Cosmos works is it spins up what it calls physical partitions, which have a 10 gigabyte limit. And when you write your data in, you create it and give it a partition key, which is something to say which partition it should put it in, that document in. Now there is a 10 gigabyte limit for a partition key, so you can only store 10 gigabytes of data for a given partition key. So you've got to be slightly careful about what your partition key is. And you want to try and keep your data relatively balanced between each of the partition keys. You don't want, say, 80% of the data going to one partition key. If your documents are larger than 2 megabytes, you'll need what's called an overflow mechanism. So Cosmos will only write documents up to 2 megabytes in size. But you can store it in something called blob storage, or they have an attachment server as well. But you have to roll your own. So if you're going to overflow, it's worth having another look at whether you can split your documents up or something. The next poor piece was the out-of-the-box monitoring and metrics in the Azure portal aren't very good. They really don't tell you enough information to tune it, and they appear to be relatively buggy at this point. I'm pretty sure that Microsoft over time will improve this drastically, so I think what's going to happen is that it's going to get a lot better as time goes on. And the last one is that the initial connect time, so for the client web service, it can take a long time to initially connect. So as it warms up a node, that can take many seconds. So for serverless solutions like Azure Functions, you may find that to be a bit of an issue. And Microsoft are actively working on that one, but right now you can wait up to 4 or 5 seconds on the first request to your service. Okay, so we said storage and compute are separated. That's only part of the story, really. So I've described earlier that we store our data in partitions. And when saying compute is separated from storage, it makes the huge assumption that all of your operations are balanced, so they hit each partition key evenly. If that's not the case, things go a bit wrong. So how does Cosmos hand out the request units that you've provisioned or RUs? It does this by taking all of the RUs you provisioned. So say I've got a database and it's been broken into 10 partitions and I've bought 10,000 RUs. What happens is that each one of those partitions gets 1,000 RUs each. So if you need to do something that requires 3,000 RUs on one particular partition, you can't do that. You'd need to buy 30,000 RUs. So that's one problem. The second is the RUs are metered by the second. So keeping a partition relatively balanced for computer I/O every second is not as likely as you think. So for instance, if you're on say a sales database, you would think that, say 10 customers might be interacting with your system at a given time. So all of the load will be on the partitions that those 10 customers' data are in. The result of that is you have to over-provision on the compute. But how much you have to over-provision will vary depending on your workload and your testing. And it's relatively easy to figure out the provisioning. Okay. So does it actually work for us? So here's a table showing what a couple of the, we'll now compare a couple of the measures that we were interested in as a business. So the first one was, how much is it costing us? So you'll see in the light green here, our previous solution in table storage. And then this is our Cosmos one, the one that's up and down quite a bit. That's because we've got it, when we were doing this, we were tuning stuff fairly aggressively. So we were adjusting the request units or RUs up and down a bit on Cosmos. In reality, we've decided we'll just wear that highest peak there is what we'll actually provision now. So you'll see it does add a bit. So it gets up to almost 3 times the previous cost. But that's in what Azure costs us. So the CosmosDB costs us. But in terms of how much management we're not having to do, we get a significant saving in manpower with this solution. And then let's have a look at our latency profile. So previously, and table storage when we looked at it was about the best solution for writing that amount of data into a cloud service. So here's the latency profile of requests into that document storage. So the table storage used to take up to on average about 140, 150 milliseconds, even out to 250 milliseconds quite regularly. With Cosmos, that latency profile suddenly jumps an awfully long way to the left. So it's about 1/10 of what it used to be. And it's much more, it's a much nicer curve on it. So we can be relatively confident of any operation being done within 50 milliseconds. And there's almost no tail on it. So they offer a 95% SLA under 80 milliseconds for writes. So this is mainly writes here. And you'll see that 80 milliseconds, you can see there's very little after the 80 milliseconds. So their SLA is pretty accurate. And we've never seen this blow out. So these numbers are pretty consistent even over a long time. And for this blue one, that also included our compute time in our Azure Functions. So we were looking at how fast our web service that wrote into each of these was in each of them. So that's including a whole bunch of stuff that Microsoft don't include in their SLA, and it was still well under their SLA. So that's how fast that was. So that sort of makes it reasonably compelling that Cosmos is a good solution. But now that we've actually done it, we've suddenly got a high availability solution. We didn't have one before. And we don't have to do very much for that to work. All we had to do was flick a switch to get high availability for our data. We've got a disaster recovery plan. If one replica fails, we'll just move over to the next one. And we can, it's sort of 20 minutes work to add another replica if we decide, oh, well, we want it stored in 3 locations and not 2. It's very almost completely managed. So we have to do very little to keep anything going. We certainly don't have to go and tune indexes or any of these things. The simpler programming model made the cost of development so much lower than it was for the table storage solution. And as long as you can keep it balanced and get your RU allocation correct, in theory you've got unlimited scale. So Microsoft will just keep adding whatever it is that's behind Cosmos as you keep buying it. So some people will say, oh, well, it costs more. Can we get that down? And the answer to that, in fact, turns out to be yes. So Microsoft have announced a new, it's called managed, reserved instances, which is a new commitment plan where you get a significant discount. So if you sign up with Microsoft and say, will you buy so many RUs from you for 3 years, we guarantee we'll buy them for 3 years, they'll give you I think it starts at 35% discount and goes up from there depending on how many you're buying and how long you're willing to sign. So that gives you a very significant discount. Right now, Cosmos has one master, so you can only write to one of their instances, and the others are basically read replicas. They do have a multi-master, which is active in private preview, which will be out GA very soon, but you can definitely sign up to the private preview. You just contact Microsoft. That will be particularly good for write-heavy workloads like ours. So we'll be able to push data to both data centers at once. Okay, and the other way you can get the cost down is knowing where your RUs are actually going and optimizing based on that. So you may be able to delay your writes for milliseconds and therefore push them into the next second and keep things balanced and reduce the RU load required. And tuning your indexes is where you can get the most bang for buck there. It actually, on writes, it costs quite a lot to have the indexes generated. Okay, so in conclusion, Cosmos is a great solution for many problems. And remembering that it's Microsoft's way to win is to make lots of products in a given space. So Cosmos may not fit your niche, but Microsoft probably have a managed database solution that does if Cosmos doesn't. And really a lot of their solutions in this space are at different levels of management. So Cosmos is the most managed of those, in my opinion. So when it suits, it's very easy to maintain. There's very little we have to do other than just keep an eye on our RU numbers. Okay. So for anyone who wants a bit more information, I've included a link to the CosmosDB website, and then I've added a link to the Azure reservation. So that's the managed where the billing cost saver. That's where you can sign up for multiple years. And if you'd like to contact me, my email is bryden.oliver@quest.com. I've been there 18 years, so that email address is likely to keep working for another 18 years, I hope. And if you're interested in seeing what the product looked like, you can have a look at spotlightcloud.io. And now I will hand over to Peter O'Connell, who will give you a demonstration of what this was all for.
Great, thanks, Bryden. I think you gotta take the. You might have to hand over control, do you?
Yep, I'll make you presenter here.
Oh, great, thank you. So, oh, is it showing my main screen? I think is it?
Yeah, it's not coming through quite yet. Ah, there we go. I can see your screen.
Okay, I got two screens, so the wrong one, I think. Okay, so hopefully you should see it there now. Let's minimize a few things here.
Yep, I can see it.
Great. Where's my mouse gone? So thanks for that, Bryden. I'll be very brief here because I don't want to do a product pitch or anything, but I just wanted to give you a sense of what we did with Cosmos. So the challenge we had from a product perspective going into this is that we had a database performance monitoring tool. We use it on SQL Server. We'll be doing Azure SQL Database very shortly, and hopefully eventually we'll end up doing Cosmos as well. But we are currently, we wanted to build this into a SaaS-based offering. So we had, for the last 20 years, this as an on-premise solution set, and it collects an awful lot of data very often. So as any kind of monitoring tool, we'll collect up to about 200 metrics, some of them every second, some of them not so frequently. It could be across hundreds or thousands of database instances. And when you've got no on-premise repository, it meant that our data collector had to collect that in data, push it into Cosmos or into our cloud repository, have it ingested very, very quickly, and have it updated back on screen almost instantaneously. And the response time, because we had an existing user base which are used to the kind of response times you get from a typical on-prem desktop tool, they expected response times that were commensurate with what they were used to. So it presented a pretty big engineering challenge from our perspective. And this is what we came up with. This is what we call spotlightcloud.io. And this is connected up to a number of SQL Server and instances, SQL Server, Windows, and Linux. These, as it happens, are hosted on Azure instances themselves, but they could just as easily be on-prem. And as you go through it, again, you'll notice here the response time is really, really fast. And before we actually migrated to Cosmos, and when we're on different kind of storage services within Azure, there was quite a bit of a lag time. You know, our response time could vary quite a bit. There was much less consistency. It's not perfect now, but it's very, very good. And given the volume of data that we put over and back, it's pretty impressive. You know, this is just a homepage here, which is just highlighting the kind of the overview of say your SQL Server performance. You can drill down into any number of different diagnostic drill downs. Here we're looking number of concurrent sessions and so forth. But probably one of the more impressive tools that we built into this is what we call Workload Analyzer. And this is where I suppose the real power of something like having cloud compute behind you comes into its own. So this allows us to cut and dice a workload. So we can look at a particular workload here. I think the time range I've taken here is 3 days. But there's two things, I suppose. When you do this on premise, and for a traditional monitoring tool, you store all that data, you keep detailed data. Typically the strategy is, look, we can't keep that kind of detail for very long, because if you do, the repository that we're storing all our performance data in gets bigger than the thing we're monitoring. It gets prohibitively expensive. So then you go and you take that, you aggregate it, and you do some statistical analysis of that. But with this, because we've got it stored in the cloud, we can keep lots more data. So officially we keep up to a year's worth of data at any one point in time, which means you can do much longer trend analysis. And even if you could store it on-prem, the grunt compute power you'd need to go and do analytics on that, you'd either be waiting all day for it, or else you'd have to spend a fortune. So what Cosmos and generally our cloud implementation has allowed us to do is take vast amounts of data and cut it, dice it very, very quickly. And in this case, for example, you can get top SQL here across a 3-day period in, after, it's because I was waiting too long, in a matter of seconds, right? So you can get that kind of analytics back and presented to you in a very short space of time. And it's by no means unresponsive in terms of its UI performance as well. So for example, that was one of our key concerns coming into this kind of implementation. Give an example here where we're pushing up SQL text and SQL plans, and we had a really nice tool that we used to have as a plugin to Management Studio for plan viewing. I thought definitely from a product management perspective we'd never managed to do this in a browser UI, but here we are. So this, not only do we manage to get it into the cloud very, very quickly and process it very fast, but we've got enough grunt power there to take a UI as complex and as intricate as this and make it responsive enough to put into a browser. So from that perspective, it's been hugely impressive for us to be able to bring to life that capability, and it's certainly giving a kind of a new lease of life to our product lines, being able to kind of reinvent them in that way. And what we're looking forward to in the future then is taking it to the next level. So it's kind of opening up a Pandora's box for us in that we can now start looking at things like machine learning, collective intelligence, and so forth. And even here we've got some basic examples of that. So we've only tipped in the iceberg, but you can go in here and we'll run a query across our entire data set to give you stats on, for example, how many of what particular types of SQL Server are installed. So, that ran across our entire data set there, right, of 11,000 servers. And then we go back into another one, which is probably slightly more impressive in terms of Waitopedia. Here we take weight stats from SQL Server, we save them, so we look across, again, our entire data set, and we start doing some queries across that to see, well, what's the most common data set or weight type that you have across the entire data set of all our users. So SOS scheduler yield. And you see here, thanks to Bryden and team from Australia, some of the Australian humor coming in here. This is the most common one, common as muck, FS header, RW lock is as rare as hen's teeth. So we can churn out that kind of analysis very, very fast and very effectively across a pretty enormous data set. So I'm not going to take up any more of your time here. I really appreciate the opportunity just to show you this. If you'd like to learn more about this, go to spotlightcloud.io and you can play around with it and get free trials just like any other product. But I'll leave some time now open to you to do a question and answer with Bryden and I'd learn from his knowledge and some of our trials and errors.
All right, great. Thanks a lot, Peter. So at this point, if anyone does have a question, you can type it into the Q&A box and we'll answer it. It is pretty cool to see that the Azure backend is being used with the Spotlight Cloud. That's super cool to see.
Yeah, it's been pretty exciting for us, as this came to life, and particularly, like as Bryden said, first of all, your first big concern is, can we get the response time to make this really responsive and work from a UX perspective? Mm-hmm. Then, of course, you get on with the GDPR last year, for example. One of our key concerns is we're going across Europe, and I think we've got a good few folks from South Africa on here as well, being able to have the portability to move across data centers relatively easily. So if you wanted to deploy in the South African data center or the German data center, we could do that. And again, that was one of our motivations for going to Cosmos. And then, of course, there's the DR side of it as well. Yep. So there's been a lot of peripheral benefits for us. Yeah.
And we got one question that came through, and so basically other cool features we need to keep our eyes out for. So, as you guys were looking at this, is there anything that's on the edge that you guys are looking at, from the cloud that you're going to be being able to build in?
Bryden, I'll leave you respond to that one.
I presume we're meaning in a Cosmos perspective.
Yep. Right.
So, all right. So there's probably not a great deal of new stuff that we've been made aware of that's coming down the track. What we do need to explore greatly is what we might do about cold storage with Cosmos, and we're certainly talking to Microsoft about that, simply because one of the problems you get here is you have to have request units provisioned for anything you're storing. So you're paying quite a reasonable amount for that. So it is of high value to be able to have that worked slightly differently, and you had some cold storage that was automatic out of Cosmos. That's probably the only one that we're actively pursuing in any way. Everything else, it just came out of the box already. We're pretty happy with the way it's all worked out from that perspective. So I think what they've done is Microsoft have gone out and found out the pain points that every customer had, and they've just gone and hit every one of those big pain points with Cosmos.
Right.
So they manage all of those pain points for you now.
Right. And with Spotlight Cloud itself, is there anything on the roadmap that would be good for people to keep their eye out on?
Yes. So our first supportive call with Spotlight Cloud was monitoring SQL Server. So it was taking on-prem workloads and pushing them into the cloud and doing the analysis on it. But right now we're working on cloud-to-cloud monitoring, and at SQL Pass we hope to be showing a preview of Azure CosmosDB monitoring through Spotlight Cloud. And the infrastructure around that then varies slightly in that our data collector and ingest is working directly cloud to cloud. So it hopefully, our whole notion is kind of, monitoring from the cloud, built in the cloud. Once we've got that, then we're going to very quickly knock out things like managed instance, and then hopefully our ambition is to turn our sights on other platforms such as Cosmos and Azure Postgres and so forth next year.
Okay, no, that's excellent. The last question we have here today is, are you it's kind of a validation that you're using CosmosDB to store all of the underlying data?
Yeah, Bryden, I think we're pretty much there, aren't we, in terms of our underlying data at this stage? I think 90% of it is in Cosmos, if not totally at this stage. Isn't that correct?
Okay, so all of the performance data you can see here is all stored into Cosmos. Right now we've got a couple of other bits that are still in relational databases, but they're ones where it probably makes more sense to store it, like, for instance, our user data, the user records. So
right.
And but yes, all of that performance data is definitely being stored into Cosmos.
Great.
And quite comfortably.
Right. Okay. Cool. We don't have any more questions in the queue for today. So with that, I think I'm going to wrap things up. And thank you, Bryden, for coming and joining us today. Thank you, Peter, for coming and talking forward. And we're looking forward to having you guys having Quest as a sponsor for the Cloud User Group, for the Cloud Virtual Group for the next year.
Great. Thank you very much.
Yep.
And thank you for having us.
All right. And at that, I'm going to...
Thank you, guys.
And thank you, everyone, for joining. And at this point, we will see you in 2 weeks.
Thank you very much. See you.
Bye.
Thanks, guys.